Hello everyone. First of all, I express my heartfelt gratitude to Emertxe Technologies for providing us opportunity of this internship. I, Ms. Shravani Chaudhary, with my fellow teammates Ms. Pranjal Kantale, Ms. Hardika Bhadarpurkar and Master Harshal Patsange, we are excited to present our project named as IoT-based project Home Automation. We are currently pursuing degree in Bachelor's of Engineering in ENTC department from Sandeep Institute of Technology and Research Center, Nashik. Without further ado, let us take a glance on table of content. In the upcoming slide, we are going to look about the project, about the internship, topics learned in this internship, what is IoT, what is embedded system, CPP, OOPS concept, about the project, implementation of the project, and derive conclusion on the same. About the internship. Internship was provided by Emertxe Information Technologies, Bangalore. The duration of internship was 4 weeks. It was organized, structured, and standard program. Learning with implementation. For student doubt section, they provided us Moodle LMS, free resources and tool, project based learning, and they also had weekly evaluation for student. Now coming to the learning part, they taught us CPP programming, OOPS concept, IoT introduction, embedded system, workshop. We also discussed and implemented peripherals, Arduino programming, PixMLab simulation, Blink IoT app, home automation project. What is IoT? IoT, the Internet of Things. Internet means network, things means object. The combination of object with the help of network, Internet. IoT is the network of physical objects, collection of electronics, software, sensors, and network connectivity which collects and exchanges the data. Let us see the ecosystem of IoT. There are 7 components of an IoT ecosystem, namely IoT devices, network, security, gateway, the cloud, application, and user. Now, I request Ms. Hardika Bahadarpurkar to give us glance on another topic.
So, hello everyone. My name is Hardika Bahadarpurkar. So, let us see what embedded system actually is. An embedded system is a combination of computer hardware and software designed for a specific function. It is a computer system which is the combination of processor, memory, and input-output peripheral devices. There is a little bit difference between embedded systems and IoT. The difference is that embedded system is a subset of IoT. IoT includes IoT device, IoT gateway, network, cloud, and applications. And because embedded system is a subset of IoT, it includes only two sets. And the two sets are namely IoT device and IoT gateway. Here are some types of embedded systems. The first type is real-time embedded systems. It includes self-driving vehicle control, aircraft control systems, and medical devices and patient monitoring system. Second one is stand-alone embedded systems. It includes digital cameras, music players, and washing machines. Third type is networked embedded systems. It includes mobile security systems, ATMs, and point of sale systems. Fourth type is mobile embedded systems. It includes cell phones, laptop, and smartwatches. Here are given some examples of embedded systems. It includes mobile phones, cameras, MRI machine, robots, cell phones, metro, washing machine, cars, and etc. They have taught us C and C++ programming from basics to very advanced level. Now I would like to request my friend Pranjal to continue further.
Hello everyone, my name is Pranjal Kantare. Let's have a look on what were the requirements of our project home automation. Garden lights control, temperature control, heater control, water tank control, inlet and outlet valve control, display water volume and displaying the progress and notified on the mobile app, Blink IoT and CLCD with automatic actions. The main components required for our project are Arduino UNO, PiximLab, and Blink app. PiximLab is used for simulation purpose. The IDE and compiler which is used for our project is Arduino UNO Software IDE. Arduino UNO is a microcontroller board and Blink app is a cloud platform used to control our project. Then the peripherals which are required for our project are LEDs, temperature system, CLCD, LDR, serial tank that is serial communication and Ethernet shield. Arduino UNO is based on an Atmega 328P microcontroller. It is easy to use as compared to other boards such as Arduino Mega board. The board consists of digital pins, analog input, output pins, shields, and other circuits. The Arduino UNO includes 6 analog pin inputs, 14 digital pins, a USB connector, a power jack, and ICSP that is in circuit serial programming header. LEDs and temperature systems are used for garden lighting control. Then CLCD, which is character LCD, is used to displaying the temperature inlet and outlet valve on our LCD. CLCD, I2C, liquid crystal I2C CLCD is used for our project. Then remote serial tank is used for water control. ETH-W5500 Ethernet shield. The W5500 chip is a hardwired TCP or IP embedded Ethernet controller that provides easier internet connection to embedded systems. W5500 enables user to have internet connectivity in their application just by using the single chip in which TCP or IP stacks. LDR, which is light dependent resistor sensor, and LDR is a component that has a variable resistance that changes with the light intensity that falls upon it. This allows them to be used in light sensing circuits. The resistance of a photoresistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. PCF8574. The PCF8574 is a silicon CMOS circuit. It provides general purpose remote input output expansion for most microcontroller families via two lines bidirectional bus. The device consists of an 8-bit quasi bidirectional port and I2C bus. Now moving towards our pin diagram. Pin diagram shows the A4 analog pin of Arduino UNO board is connected to CLCD SDA pin which is used for I2C communication purpose. Then analog pin A0 is connected to our temperature sensor for reading analog temperature values. Analog pin A1 is connected to LDR, that is light dependent resistor sensor, for reading analog light intensity values. The digital pins 10, 11, 12, 13 of Arduino UNO are typically used for SPI communication with Ethernet shield. Pin number 10, Slave Select SS pin, is used to select Ethernet shield as an active SPI device. Pin number 11, MOSI, that is Master Out Slave In pin, is used to send data to our Ethernet shield. Pin number 12, MISO, that is Master In Slave Out, is used to receive data from our Ethernet shield. Pin number 13, serial clock pin, is used to provide a clock signal for our SPI communication. Then reset pin is used, RST, to reset shield if needed. Then Blink virtual pins are also connected to interact with our Blink app. Pin number V0 is used to monitor our cooler pin, which is called as our cooler pin. Then V1 is connected to our temperature sensor, which is used to sending data to our Blink. Then V2 is used as a heater button, which is used to control our heater action through Blink app. Pin number V4 and V5 are connected as inlet valve and outlet valve respectively to monitor our inlet and outlet valve through our Blink app. Thank you.
Hello everyone, my name is Harshal Suresh Patsandi. I will continue this PPT presentation further with a project implementation. First, I will explain you the code which we are going to use, and finally, at last, I will show you the final simulation. Now, this is our main code, which is home automation link control. To make it simpler, we have used some CPP and H files. First, we will see every CPP file. In our CPP file, we have some functions to execute, and for every functions we have written a code. For example, for brightness control, we have written an LDR sensor value will be stored in ADC val, a variable. Then that variable will further be with a value of 10 bit. That 10-bit value will be divided by 4 to bring it to an 8-bit value, and that's subtracted from 255 to reverse the brightness. Same with the serial tank.cpp. Some functions we have written, like for enable inlet, we have given inlet valve enable. These functions we are going to use in our main code. For temperature.cpp, we have our heater, cooler, temperature sensor input output given, and how to read a temperature and how a cooler will be controlled. That all code we have been writing here. Let me give an example. Float read temperature is our function in which we are going to read the readings. We are going to read the readings from temperature sensor, and we are going to store it in our temperature variable. But we need some formulas so that we get an accurate temperature. Here we have used this formula to convert the following readings into voltage and then multiplying it by 0.01 to get the actual temperature, which will be 0.1 degrees Celsius per voltage. And this .h files we have used to give our pin, which pin we are using. Temperature system we are using 5 and 4 pin. Serial in a main.h we are using this pins V1, V0. In LDR.h we are using A13. And now coming on to our final code. First, to connect our code the, with the Blink cloud, we need to define these three things, which is template ID, template name, and auth token. Further, we have to include some libraries, like for LCD, we need liquid crystal. For communication SPI protocol, we need SPI.h. For Blink Cloud, we need Blink Simple Ethernet, and so on. We have to include all the .h files as required. First, let's get started with the code of LDR system. First, we will see our void setup and void loop. In our void setup, we have given init LDR, which we have defined, which we have created a function and written a code. You can see here init LDR, init LDR. This function has been written in our CPP file. Further, init temperature system, init serial tank, which have been written in our .cpp files. In the start of our code, in our simulation, we will need to actually set up our LCD. For that, lcd.init backlight clear home, and we have to print home automation. At the start of the simulation, it will show home automation, and then after a delay of 1000 milliseconds, it will show T is equal to NV, which are temperature and volume basically. In our loop, we are giving the functions which we need to continuously iterate. The functions which are need to be iterated continuously are been given in our loop function. Brightness control. Now string temp. The reason why I have used string temp is the temperature which we need to display is in not is not in the string form. We need it in the string form so that we can display it on our LCD. After converting the temperature into string, we are setting the cursor and printing the temperature. Volume also we are going to print. As we know, blink.begin we need to use to start or to communicate with the Blink cloud, Blink app we have, and blink.run to continue run. Further, with our functions which are written in the main code, we are going to discuss it. Cooler vpin, we have a param as int, which is we have to get that value from the Blink cloud, but in the form of integer, and we are going to store it in cooler switch. Same we are going to do for heater switch, and we are going to check whether the cooler switches are on or off. Further, we are going to give some conditions which will be based on our temperature reading we have, the temperature reading we have. We are going to update the temperature reading first. Virtual write is used to write the temperature on our Blink app, the gauge we are going to use. For handle temp, we can see read temperature. If read temperature is greater than 35 and heater switch is equal to on, then we have to turn off the heater switch, turn off the heater control. We have to virtually write. Virtually write means we have to give Blink code what to do. Like it will turn off the button which is actually on while the simulation is on. Now here we will see this function. In this function we have if the read temperature is greater than 35 and heater switch is on, then it will turn it off and it will write it on our Blink app with this virtual write. Then it will set cursor and print LCD will print HDR off. Same for handle cooler. I have written it extra. It is extra actually. If cooler switch is on, then we have to set cursor and it should print clear on for some amount of delay, and then it will just wipe off after 2000 milliseconds. Same for inlet VPN, we are going to accept it as parameter as int. Then we are going to enable the inlet, then set cursor and then print inlet flow on, else it will be off. Same for outlet VPN, outlet switch, enable outlet, set cursor outlet flow on, else it will be off. Void handle tank. One more if else condition we have given. In our if condition, if tank volume is less than 2000 and inlet switch is equal to 0, then it will enable the inlet, update the status of the inlet valve on our Blink app, and then this will be displayed on our LCD screen. Again, a condition where tank volume, it will check if the tank volume is above or equal to 3000, then the inlet switch will automatically get turned off. This is the code for it. And the void setup and void loop as we discussed at the starting of our code. Now we have discussed the code and we are going to see the final simulation. Let me do the setup and then we'll get started. We need to load our X file. The temperature and volume we can see. Let it load first. After loading, we can see the inlet valve is automatically turned on and the volume is increasing. And according to the conditions given, the inlet valve should turn off at 3000 volume. Now here we can see at 3000 volume, the inlet valve has been turned off. Same if we press the outlet button, the outlet will turn on and the water will start to flow. But again, if the water goes Below the 2000 volume, the inlet valve will turn on automatically. Let's get started with the next project temperature system. Here I'm turning on my heater switch, and then we can see how our temperature will increase. Now according to the conditions given, when the temperature will reach 35 or will cross 35, then heater switch should turn off automatically and we will turn on our cooler switch. Now on 35, you can see the heater switch is turned off and now we'll start our cooler. The cooler will give us our original temperature, which was before we can name it as room temperature. Now as you can see, the cooler switch has been turned off as the temperature reached 27.34 degrees Celsius. Further, the third project we have is LDR or garden lights. If we turn down the LDR to its lowest, let's assume it is the morning. Then at the morning, the LED will be off. And as soon as we turn the LDR, sensor will sense that it is night and the LED will turn on. These are the final three projects. Let me explain you the components in the spare parts. This is LED strip, this is LDR, temperature system, this heater cooler system we can say. This is Ethernet which is required to connect our Arduino. Let me explain you the components here. This is LCD, this is LED strip, this is LDR sensor, this is heater cooler system, this is Ethernet which is used to connect our Arduino or our controller with the Blink app. Further, this is the microcontroller where we have loaded our hex file, and this is the serial tank in which we have used COM7, and for our Arduino we have used COM6. This both are serial port connection, COM6 to COM7, and with the help of the serial communication, the tank has been filled. Thank you. And tank has been filled. Several bullets. Now, as we have seen the code as well as simulation, this is the conclusion we have. We have used Blink IoT application, Pixim Lab as a simulator, simulated a home automation where we have created a garden light system, a temperature system, and serial tank system where the inlet and outlet can be controlled, as well as we can see the volume on the gauge widget of our Blink app. And finally, thank you. This is the end of our session.